Okay, let's analyze the question part B now. Logic circuit need to be designed to count according to one of the following two ways based on an input I. Okay, if the input is 0, it will be a modulo 4 counter, so it will be counting like 0 1 2 3 0 1 2 3 like that, right? So it is just one by one, just counting upwards all the time. Okay, but if the input is 1, it will be counting 2 by 2, like 0 to 0 to like that, right? Because it is skipping 1, right? Always it is skipping 1, so it is skipping 1 and 3. But there could be another configuration which will start from 1 and go like 1 3 1 3, right? So this is a counter which count 2 by 2, right? Based on the place it starts counting 2 by 2, it will be in a different loop. Okay, so let's see how we can develop a state transition diagram for this particular circuit. Okay, so here are some instructions also given. I is selecting an interval essentially, right? 0 for counting 1 by 1 or 1 for counting 2 by 2. Okay, if the count is S0 is count is 0, right? So we have S0, right? So here if the count is 0, we can use this, right? So we can keep counting 0. I mean there is a counter anyway, right? So there are this is a modulo 4 counter maximally, so it will be just 4 states, right? 0, S1, S2, S3, right? So if the count is 0, it will be 0, count is 1, it will be 1, count 2, count 3, again going back to 0, right? So now let's see what are the transitions, right? If we are at count 0 and we get a 1 in our input, what it will do? 1 in our input means it's going to count 2 by 2, right? If I is 0, it will be I is 0, it will be counting 1, right? If I is 1, it will be counting 2, right? I equals 1. Okay. From here, if the current count is 1 and we are I is 0. If I is 0, we are counting 1 by 1, right? So now our state the value is 1, counting 1 by 1. If it is counting 1 by 1, means I equals 0 condition, it will be going to 2, right? 1 2. Again here also, if I equals 0, it will be going to 3. I equals 0, it will be going to 0 again. Okay, now here what will happen if we are at S1 and we get I equals 1, so we have to count 2 instead of 1, right? So we'll be skipping 2 and we'll be going to 3, right? We'll be going like this. So this is I equals 1 at the state 1. Okay, so now we have all the input conditions covered for S1. About S2, we have I equals 0 condition covered. What happen if we have I equals 1 in our S2? Then we have to skip 3 and go directly to, or I mean go to the next state, right? So it is counting 2 by 2, so it will be going like this. Okay, so I equals 1, this one also. Okay, so here also now I equals 1 condition satisfied, then I equals 0 also covered, right? So that's correct. Then how about in S3, what happen if we get I equals 0? Okay, that one is already determined. In S3, what happen if I equals 1? So we have to skip the next one and go to the next one, right? So we'll be counting 2 ahead, right? So yeah, a little bit difficult, right? But yeah, let's try. Okay, it will be going to 1, right? 3 0 1. Okay, so this is also I equals 1. So this is our state transition diagram. In 0 also double check, we can have I equals 0 transition and I equals 1 transition. So we have all the possible transitions covered now. Now the challenge is to design a circuit to actually follow this state transition diagram, right, or state machine. So how to do that?